Alright, good morning, Algebra 2. Let us take a look right where we left off on our notes. I'm on the bottom of, it looks like I don't have a page number here, but it's where we left off yesterday, the 8.5 logarithm stuff. We just got done with this checkpoint, so we're right down here on these warm-up exercises. I'm going to go through these kind of quick. Remember, anytime you want, you can kind of pause this or rewind this video and go at your own pace if need be, but I'm going to go semi-quickly, while also trying to explain things. So, the log of 100. Remember, if there is not a log written here, it's log base 10. This is log base 10, log base 10. So what I ask myself is, 100 is 10 to the what power? And that answer is 2, because 10 squared is 100. And then I do the same thing with 10,000. So there are 1, 2, 3, there are 4. So this is a 4 here. Add those together, you get 6. Same thing, 5 to what power will give me 25? That's 2. 5 to what power here will give me 125? That's 3. Add those together, you get 5. Here is where you want to try to make these bases to be the same thing. Like, since this is log base 5, I'm going to rewrite this as log base 5 of 5 squared squared, which by the way turns into 5 to the 4th. And if you remember from yesterday, the reason why I did that is because now this log 5 and 5 kind of cross each other out, and the answer here is 4. And the last one here, I'm going to take 2 times this. I'm going to do the same thing that I just got done doing, which is change that 25. Because this base here is 5, I'm going to get this to be 5 to the something, which is 5 squared. These cross out, and your solution here is not 2 squared, it's 2 times 2, which is 4. So, a couple warm-ups. Let's use that down here with some properties. This is going to be the weird stuff. Here we go. The first one is the product property. What you need to know about the product property is that if you have 2 things multiplied under or with 1 logarithm, I can actually split this to be 2 logarithms. Or all of these, so maybe you even want to make a little note of this, all of these properties work backwards as well. So I'm going to split all of these 1 logarithms into 2, but you can also go the other way around, meaning if you have 2 logarithms to the same base, you can combine them to be 1. I'll show it I mean in some examples, but all of these properties work. I'm going to use the term vice versa. Vice versa, meaning you can, if this is 1 log, you can split it to 2. If it's 2 logs, you can split it to 1. Here's how you split. This first one, if it is a multiplication in this log here, meaning you got 2 numbers multiplied together, you can actually split that to be log base b of u plus log base b of v. Multiplication splits to addition. Note, maybe you even want to note that off to the side over here. Where this division one, let me switch colors. This division, this will split into subtraction. So multiplication is addition, division splits into subtraction. So this actually will turn into the log base u minus log base b of v. So multiplication turns into addition. Division turns into subtraction. And the last shortcut that we're going to use is if you have a power up here, what you can do with this power is you can kind of take it out in front. Only if it's a logarithm you can do this, and you can make it a coefficient. So in the end, this will turn into n log base b of u. And I'm going to show you where we're going to use all this here in a second. But wanted to make sure we talk these properties with the letters first. If you need to, go ahead and pause and make sure that you have this written down somewhere. So I'm going to go to the next page. Here we go. Let's do some examples. Scrolling up. Your book tells you to do pages 496, number 5 through 8. I wrote them on here so that I don't have to sit there and flip back and forth. But if you want to, you can either pause and go to this page and see these, or you can just kind of write them down as I have here. So I'll give you a second to pause and do that. All right, and here we go. Equals, 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 and equals. Let's start right here. I'm going to start with number 5. I see this as being multiplication. So what I'm going to do is I'm going to split this multiplication into addition using the same log and using these 2 numbers here. So I'm going to split this 1 logarithm into 2. I'm going to split it into log base 3 of 3 plus log base 3 of 9. Because this is multiplication, if I go back a page and scroll all the way down, multiplication here turns into addition. That's where I'm getting this plus right here. That's where I get this plus. So the log base 3 of 3, if you remember from yesterday, crosses out. It leaves me with a 1. Plus log base 3 of 9 is 3 to what power gives you 9? The answer to that is 2. The answer here is 3. I'm going to use another rule here. I'm not going to use the multiplication rule. I'm going to use the division rule, meaning I'm going to change this to be log base 3 of 1 minus log base 3 of 3. Why? Because now this is very helpful, because log base 3 of 1, we know from yesterday, it doesn't all the way cross out, but we know that it's 0. Log base 3 of 3, this crosses out to give you 1. You end up with negative 1. Down here, log base 2, 4 to the 5th. This is my exponent shortcut. I'm going to take this 5 and write it as a coefficient in front here. So I end up with 5 log 2 of 4. Where 2 to what power gives you 4? The answer to that's 2. So this ends up being 5 times 2, which is 10. And the last example I'm going to do with you here, switch back colors, is I'm going to take this 3. I'm going to use kind of 2 different ones. I'm going to take this 3 and put it out front. So I end up with 3. And now I'm going to go log base 5 of 1/5. And now I'm going to use another rule, which, since this is division, if you go back a page, division means subtraction. So I'm going to change this into 3 log 5, 1 minus log 5, 5. The only weird part is you have to make sure that if you split this twice, the second time around, you have to make sure that this goes in parentheses, because it's 3 times this whole thing. So I end up with 3 times log base 5 of 1, which we know is 0, minus log base 5, that's a 1. I get a negative 3. So I'll give you a second to kind of digest. If you need to pause and look at those, I'm going to pause and scroll down and start talking about using these properties down here. All right, a few things left, and then we're going to call her good. Here we go with using properties of logarithms, where it's going to give you some decimal points here. And notice I switched it to grape as a color to try to keep us a little interested. That's exciting, right? All right. I am going to switch and use my properties on these 3 right here, and then I'm going to use these decimal points that it gives me to try to reduce some of these things. So here we go. Log 5, 3/7. I'm going to change this using my division rule. Remember, division is subtraction. So I'm going to change it to log 5, 3 minus log 5, 7. Now, why did I do that? Because up here in my given, it tells me what log base 5 of 3 is. It's 0.683. And it tells me what the log 5 of 7 is. It's 1.209. Then your last step is simply to go to your calculator here and go 0.683 minus 1.209. I get negative 5.26. 0.526? 0.526. 0.526. So it's a way that we can, even though we can't punch this into our calculator, it's a way if they give us some decimals, I now know what the log base 5 of 3/7 is. Because I can take the log base 5 of 3 and the log base 5 of 7 and just subtract them right here. So let's try log base 5 of 21. Well, 21 is an interesting one, because you have to ask yourself this question. How do I get 21 from these numbers up here? Well, the answer is I multiply them. So I'm going to kind of rewrite this as log base 5 of 3 times 7. Why did I choose 3 times 7? Because now I'm going to split this using my properties into log base 5 of 3 plus log base 5 of 7. I'm going to use these same decimal points that it gave me up here now. I'm going to go 0.683 plus 1.209. Grab a calculator. We'll go 0.683 plus 1.209, and we get 1.892. And the last one, you're going to have to ask yourself the same question. Let's go with another fun color. Let's go, let's go clover. Let's go clover for this one. You have to ask yourself the same question. Is this 49? How am I going to get this number and this number to be 49? And the answer is, I'm going to take this 7 and square it. So I'm going to rewrite this as log base 5 of 7 squared. Because now I'm going to use my properties, and I know that I can take this 2 and drop it down in front. So I end up with 2 log base 5, 7. Since I know what the log base 5 of 7 is, I'm going to go 2 times this number right up here, 1.029. Grab my calculator, right here. I'm going to go 2 times 1.0209, I'm sorry, not 029, 209, and it looks like I end up with 2.418. 209, try that. So that's using a couple, if they give you some decimals here, some logarithms, you can use these properties to work around, even though you can't punch these into a calculator, you can use some properties to work around that. All right, I'm going to give you a second to pause here. I'll leave it up here. I'm going to give you a second to pause, digest this information, and then I'm going down here to example 3, and then we have one last thing to talk about after that. All right, here we are in example 3, expanding and condensing. Now we're throwing some variables into this. What I'm going to do is expanding. What it's going to do is it's going to give you one logarithm like this, and it's going to be your job to split this into several logarithms. Or condensing means I'm going to put all of these under one logarithm. So expanding means you're going to end up with log and another log and a log, and you're going to have a bunch of logs. Condensing means at the very end you're just going to have one log stuff. That's the difference between expanding and condensing. So let me undo all this and let's start chatting about how we do this. First of all, I see this division. I'm going to take care of that first. So division is subtraction, so I'm going to rewrite this as log base 2 of 7x3 minus log base 2 of y. That's splitting with the division. And give me 1 second here too. I'm gonna get rid of these warm-up exercises so I have more space. And magically, just like that, they're gone. So once I have taken care of this division, which turned into subtraction, now I can adjust this. So what I'm going to do here is I'm going to take this 3 and put it out front. So I end up with 3 log base 2 of 7x minus log base 2y. And I'm still not done because I can still expand this a little bit further because I can split this 7x up. Because this is multiplication, I can split this to division. Now remember, this 3 is times this whole thing, so when you take it for the second time, if you expand it one more time, you have to put it in parentheses. So it ends up being 3 log 2 7 plus log 2x minus log 2y. There is nothing else I can do with this because I can't break 7 up into anything, I can't break x into anything, and I can't break this y into anything. So I'm good. That is expanding. Kind of, sort of. All right. Coming over here to condensing. Let's choose a different color. Let's find something fun. Ooh, how about tangerine? I can't wait. So I'm going to condense this into one logarithm. What I would do first is take care of any of this exponent stuff. Like I'm going to take care of this 2 by putting it right up here. So I'm going to do log base 6 plus log 2 squared minus log 3. I'm actually going to multiply this log 2 squared to be log 4. So I'm going to do log 6 plus log 4 minus log 3. Last thing to do, or almost last thing, I'm going to put these two logs together because this is addition right here. Addition is multiplication. So I'm going to change this to log 6 times 4 is 24. Minus log 3. This subtraction means division, so I'm going to put it under one log and go 24 over 3. 24 over 3 reduces. Final answer here is log 8. And because it's condensing, I only wanted one log when I was done, and I successfully accomplished that. So let me scroll over, give you a couple minutes to either copy this down or kind of digest this if you want to pause the video, and then we'll move on to the last page. All right, last thing and we're done for the day. Change of base formula it's called. Basically, this is a way for us to take like log base 3 of, we'll say, 12, where 3 to some power gives us 12. Our calculator can't do this because if you remember our calculator, it just has the log button, which means there's a 10 down here. Our calculator only does log base 10. But there is a way to kind of trick your calculator into doing this for you, and here's how you do it. If you have a log to base c of u, and let's say these don't work out evenly or this c is not 10, then the easy way to punch this into a calculator, if you want to get it as a decimal, is log of u over log of c. And so it's really kind of nice because you don't have to necessarily know how many times c goes into u. These will be powers of 10. So if I wanted to do this log base 3 of 12, I would simply, in my calculator, punch in log 12 divided by log 3. And I will do that with you here. Let's make sure we're all getting the same thing. So grab your calculator, clear all this out of there. I'm going to go, to figure out what log base 3 of 12 is, I'm just going to go log 3. Now your choice, log 12. Your choices are either to close the parentheses and then divide. I don't like doing that. I like to push enter and then push divide by log 3. I get 2.26. And I don't know what all these blanks are down here. It's basically trying to tell you the same thing. You can write these logs as two different things. If all else fails, we can run over this again on Monday, or in class, I should say. So, just to show you one more example of this, if you want to try this checkpoint, that would be a great thing for you to do. You can check with each other. I will put the answers to this on my desktop as a picture, so you can look at them if you want to. But I'm going to show you this number 5 right here together. Oh, that's convenient. So, evaluating log base 7 of 9 using the change of base formula. Since I don't know what this is, I'm just going to split this into log 9 over log 7. And go right back here to my calculator. And I'm going to go log of 9, enter, divide by log 7, enter. I get 1.129. So, I will leave the rest of these checkpoint answers on my desktop as a picture. I will even write, the picture will be called 8.5 checkpoint answers. Try these, then we'll get your assignment for later. Next lesson will be here, and this will be a lot of fun. It will be solving these things right here. It will be starting to solve with x's up here in your exponents. So, good luck.